Hello everyone, I'm Yang Xiaochen, a Huawei engineer. Today, I'm going to introduce the SFC function for reactive and standby fabrics in Huawei's Cloud Fabric solution. An SFC, short for Service Function Chain, logically connects service functions, or SFs, providing an ordered service set. Data flows pass through the SFs for check and processing. We can use the SFC function to set network paths for traffic as required. When services need to be adjusted, we only need to update the sequence of SFs without changing network configurations. This enables agile provisioning of network services. However, if the link between a leaf device and a VAS device fails, service traffic forwarding is affected. Huawei provides the SFC function for reactive and standby fabrics, with the active and standby VAS devices functioning as SFs. One set of VAS devices is deployed in each data center and controlled by the same iMaster NCE fabric system. In this way, if the active VAS device is faulty, SFC traffic is automatically switched to the standby VAS device, achieving high service availability. Let's look at how to configure SFC for reactive and standby fabrics on the controller. Before the configuration, we need to deploy and verify the environment. First, we need to deploy the service network used for testing. Log into iMaster NCE Fabric and create a tenant. Select the fabrics to be added. If the fabrics are unavailable, create them. Select the VMM domain to be added. If the VMM domain is unavailable, create a VMware or Fusion Compute domain. Next, click the Created Tenant to go to the Tenant Management page. Go to the VPC Management page and create and deploy a VPC. Then, create logical routers and logical switches for services, and complete the network pre-configuration. Drag the logical router icon to the canvas to deploy a logical router and complete basic configurations such as the service network segment and gateway. Drag the logical switch icon to the canvas to deploy logical switch 1 and configure the associated logical router and network segment. Repeat these steps to create and configure logical switch 2. Create a VMM mapping and deliver the corresponding port group to the vCenter based on the selected subnet. Similarly, create a VMM mapping for the other subnet. Next, we need to bring VMs online for testing. Go to the logical network page of the controller. We can see that the network configurations are automatically delivered when the VMs go online, and the information about the associated VM is also displayed. The environment is now available. Log into VMs and perform ping tests. We can see that the VMs go online successfully and can ping the gateway. The VMs can also ping each other across the active and standby fabrics. Now, we configure SFC for active and standby fabrics. For example, we create an SFC to deny traffic across active and standby fabrics. Go to the VPC page of the tenant and click Application Network tab. Create EPG1 and select the IP address of VM1 as the IP address of EPG1. Create EPG2 in the same way and select the IP address of VM2 as the IP address of EPG2. Then, create an SFC. Select the SFC profile for denying traffic across the active and standby fabrics. Select EPG1 as the source EPG and EPG2 as the destination EPG. Set action to deny and direction to BI and click OK. Wait for a period of time. The SFC is then deployed successfully. Now, let's verify the SFC delivery result. We can see that the VMs cannot ping each other across the active and standby fabrics. This brings us to the end of the process of configuring an SFC for reactive and standby fabrics on iMaster NCE fabric. All the operations are easily performed on graphical interfaces. In this way, we only need to focus on service paths, eliminating the needs to configure devices. Okay, that's all for this episode of Test It, Believe It. Thank you.